but then took away income to get them back on the same indifference curve. And this distance is $184. Yes, Wes? Divided by the price, except the price of z is 1. Yes?
In terms of the third problem where plugging in a two function explicitly will tell what was that the answer, do you think that's recommended, or do you lose generality when answer was by applying a button, for example?
I think that's a kind of general question. It depends a lot on the problem you're trying to solve. And so here, before tackling this example, the authors of this paper, I'm relying on, were at pains to kind of justify the utility function by finding evidence that expenditure shares have been constant over different levels of income and different prices. So that's a case where you might say, well, gee, this is a special utility function, but it seems to work for the data we have on light demand pretty well. So so you might feel justified in using it to extrapolate what demand would be for this much lower light price that people are forecasting. In general, if you don't have some empirical evidence to tell you that you've got a good choice for your utility function, of course, it's better to to be more general if you don't have a good reason for making a specific assumption. Okay. Yes. Oh, okay. Well, it might look the same. I mean, if we had a so this is a question about the angle curve. Let me try to draw another picture for you. Or maybe I can use the same one actually. I think the way I drew this earlier, in fact, suggested that z was an inferior good. Let me try this again. So let's suppose we have L and Z. We're not going to have, if we assume this utility function, by the way, neither good is going to be inferior. That's just a consequence of the indifference curves. But let's imagine we had a different utility function that did allow for inferior goods. So we might have an indifference curve like this. So we have a demand like this. Income increases. So let's say it increases to something like this. That's supposed to be a straight line. Please be forgiven if it's convexity there. If L is an inferior good, then when we increase income, we should get a tangency between this line and the new indifference curve, which lies to the left of this point. So if we had an indifference curve that did something like that, I haven't drawn this very well at all, then you'd see we get, hopefully a little bit less L at this level of income than at this one. So that would be a case of it being an inferior good. Okay. Other questions? Yes? Okay, so that's a different question that's related to this question of inferiority. That's a question I would encourage you to think about via the lens of the Slutsky equation. So remember, we've got Slutsky here, dx dpi equal to dhi dpi minus dxi dy times xi. So this is the slope and point of the demand curve. Maybe we'll draw a picture of this as well. Okay, so I need to be. Okay, so we need to first of all be careful about what we mean by steeper. And one of the first things we have to remember that's easy to forget is that we have our axes backward. So the slope of this demand curve is not dxi dpi. Instead, it's 1 over that. So the slope of this line is equal to 1 over dxi dpi, just because we have the axes sort of reversed. Okay, so when we relate the slope of the demand curve, we have to be careful to account for that. Okay, now which is sloper, that's steeper, the Hicksian or the Marshallian, is a question about whether dxi dpi is greater than or less than dhi dpi. And so let's just ask that question. Let's see under what circumstances the slope of the Hicksian is greater. So let's assume that, which means that because it's 1 over this, that means that this quantity should be greater than dhi dpi. Okay. So when will that be true? Well, this implies, just using this formula, that dhi dpi minus dxi dy times xi is greater than dhi dpi. So I've just written this expression, used the Slutsky equation to decompose dxi dpi into its income and substitution pieces. So that's this. So when is it greater than or equal to dhi dpi? Well, we've got a quick answer. This immediately cancels. So this will be true if dxi dy xi is less than 0. Okay, and so you see what I've done. I just canceled out the h's, the dhi dpi, and I multiply by -1. So that gives me this condition. And is everyone happy with this? And so now let's put some words to this condition. We can actually keep going a little bit. From here, if xi is positive, we can just cancel out. So this it implies and is implied by dxi dyi being less than 0. When is this true? That's the definition of an inferior good, that when income increases, demand decreases. It's a positive constant, so I just divide through by both sides. Yeah. It's worth checking that it's not 0, but usually it'll be positive. Okay. Other questions? So I think we've veered off into sort of problem set 5 territory. That's okay. Yes, Brian. If it's an inferior good, so I want to be careful when I say this, because so this is true, that the dx dpi is greater than dhi dpi when it's an inferior good. But when we flip around the axes, making this thing a larger number is the same thing as making this the opposite. Plus you should remember these are negatives. Yes.
I don't understand so which one is bigger?
When we're so the problem is connected to the word steeper. So if we need to decide what space we're in. So if we're in this space, so the prices are on the vertical axis and quantities on the horizontal, then that's the same as saying that the slope of this thing is 1 over dxi dpi. So if you wanted to ask whether the Marshallian or the Hicksian demand was steeper here, you'd refer to the reciprocal of this. So saying here that this is greater than this is the same as saying that the Hicksian is steeper in this space in absolute value. Yeah. Yes. For a normal, yeah, so that's right. So for a normal good, what happens here? We get an increase in price. There's a substitution effect. People substitute away from the good. So this is for x1 and x2, for example. So so we get a change in price. Let's say this is our initial budget set. We get an increase in P1. That means that we get a shift in the slope of this thing. So this piece here, we stay on the same indifference curve. This difference here is, or this is delta H. This is the change in the Hicksian part. This is the substitution effect. So that's the change in demand for good one, just the substitution piece of it. There's also an income piece, because we don't get a new income up here. Instead, we get an income down, I didn't draw that very well, but down here. So in addition to this shift, there's also this shift onto a new indifference curve. If it's a normal good, the reduction in income will result in a further decrease in demand for the good. So we get this little piece here. This is the income effect. Now, when it's a normal good, dxy is positive. This is positive, so this whole thing is negative. So this contributes a further decrease in demand. So you substitute away because the price has gone up. You reduce your demand because your real income has gone down. And so those two effects reinforce each other in the case of a normal good. Yes?
How would you take the same question number 1, but adding how to be doing something?
So the question is, how do you answer? So we answered number 1 here using Marshallian demand for how does demand change when there's a price change. The question that's being posed now is, how do you answer that if you want to keep utility constant? So how would demand change in the face of a price change, keeping utility constant? So how would you answer that? Yeah, the answer is given by the Hicksian demand function instead of the Marshallian. And so you do exactly the same kind of exercise we did when we found the difference between the Marshallian demands. Is that still up here? No, it's long gone. But we look at the difference in the Hicksian demands instead with prices before and after. Yeah. All right, other questions? Okay, I think we should finish up, or else I could tell some jokes, so I'm not that jokes. Yeah.